Hello, and welcome to this session on the training about PLAXIS Automation Basics, in which we will see how to use Python with PLAXIS Input and Output programs. PLAXIS software provides an HTTP-based API for Python scripting. This is available since PLAXIS 3D 2016 and 2D 2017 versions as a fully integrated environment. PLAXIS installer delivers a full Python distribution, various useful modules ready to be used in scripts, a Python editor, Cyty, and the necessary encryption modules. The prerequisites for using the Python scripting in PLAXIS are an activated geotechnical select entitlements, running the code with Cyty or any other Python editor, making sure the firewall is not blocking any PLAXIS applications, and of course, basic knowledge of Python language. At the bottom of this slide, you can find a few links to Python resources that can help you get started. Let's see now the general workflow for using the remote scripting in PLAXIS. First, we need to activate the remote scripting server. Then we start Cyty editor, we include the boilerplate, write the Python script, and just simply hit F5 to run the code. Let's see now each step in more detail. To activate the remote scripting server, you have to open the menu item Expert and configure remote scripting server. In the pop-up window, you need to make sure that the geotechnical select entitlements are activated, you have a secure password for the connection, you define a local port, and you are ready to start the server. PLAXIS provides a simple Python editor. Cyty can be found in both input and output programs under Expert, Python, Editor menu, or by searching for it in the Windows Start menu. Before writing any Python code, you need to add a boilerplate. This is required to allow for communication with PLAXIS. This includes importing the PLAXIS scripting library, setting up the correct localhost port and password, and defining the two variables SI and GI. The SI is bound to an object representing the PLAXIS input application, the remote scripting server. The GI is a variable bound to the global object of the current open PLAXIS model in input. This should be used when you want to make changes to the model, for instance adding a borehole or a point, generating the mesh, or starting the calculation. The boilerplate to be used is shown at the bottom of this slide and needs to be included in every Python script. Now you need to add your code in the Cyty window, and when done, save it as a Python file. The extension is .py. To run your code, simply go to Tools and click Go. Otherwise, you can also use the keyboard shortcut F5. Now, let's see the general workflow when opening a Python script. It is possible to run a previously saved script. Go to the menu Expert, Run Python Script, Open, and select the existing script from a folder. Otherwise, you can go to Expert, Run Python Tool, and select the script. The scripts should be saved in the py tools folder in the PLAXIS installation. This allows for a quick selection of the lastly executed scripts. You can also use the keyboard shortcuts. The general workflow is to activate the scripting server, select the Python script, and done. Here you can see how the Open Python script window looks. In order to open a script, you need to use the boilerplate too. The requirements in this case is to import the PLAXIS scripting library, use the same variables as before, SI and GI, referring to the server and the global object in PLAXIS. And in this case, you don't need to pass any parameters, so no password and no localhost port. This is because PLAXIS automatically recognizes both, which is easy for non-programmers. The boilerplate without parameters to be used is shown at the bottom of this slide and is to be included in every Python script that is to be opened in PLAXIS following the options explained before. In this slide, we will see the workflow for running a Python script in PLAXIS Output. PLAXIS Output runs as a separate remote scripting server. When run together with Input, you need to set up two server connections with their own port. You can see the code here. We first import the PLAXIS scripting library. We initialize the two variables by defining a new server for input program, and then we do the same for output program. Notice that instead of SI and GI, we have SO and GO, referring to outputs, server object, and global object. Output can also directly open an already saved project and close it at the end of the automation. The code for this is shown at the bottom of this slide using the open and close functions. Typically, in a PLAXIS project, you would start from input, and following a calculation, you would switch to output to view the results. Here, we will see this workflow in steps. Following the PLAXIS calculation, you would view the results of the lastly calculated phase. Here, this is phases minus 1. Remember that negative indexing is supported and will point to the last object of this listable. Then, we run the view command by passing the phase of interest as a parameter. This would open PLAXIS output and return the port number. This can be used to initialize the two variables by defining a new server for output program. The rest of the code for PLAXIS output can now be added to continue with your automation. A useful tool PLAXIS offers is a Python interpreter. This can be found in the menu Expert Python Interpreter. This is a built-in command line prompt which is quick to use, suitable for simple for loops, but not for large amount of commands. Especially useful for troubleshooting and easy trial and error for commands. Note that the connection and password are already automatically set, so no boilerplate is necessary to use it. With PLAXIS, it is possible to use a custom Python distribution installed in your own computer. There is an option to install the required components for using PLAXIS to your custom distribution. Note that the custom Python distribution will be used for the following options: Run Python script or tool, Interpreter, and Editor. Finally, it is also possible to install other Python modules to the PLAXIS Python distribution that is delivered. Despite the fact that many modules are already delivered, such as EasyGUI, Matplotlib, NumPy, etc., it is normal to need to install a different Python module. To install it, you can use the following steps. Go to Expert, Python, Configure Python Interpreter. The current directory should be switched to the one shown in this slide. Run the following command to install your required module. For instance, python -m pip install pandas.